Hello everyone. In this video, we will be studying exercise 1.3, 6th, 7th and 8th sum. So now we'll see the 6th sum. Look at several examples of rational numbers in the form p by q, where q is not equal to 0, where p and q are integers with no common factor other than 1, and having terminating decimal expansions. Can you guess what property q must satisfy? So to understand, this, we will take few examples. Okay, 33 by 8 we will take. The decimal expansion of this is 1.4.125. Then another example we'll take 329 divided by 400. The decimal expansion of this is 0.8225. Then another example we'll take 13 upon 25, and the decimal expansion is 0.52. Now what they are saying is that takes rational numbers in the form p by q. So rational numbers examples we have taken which are in the form p by q, and they are saying that they should not have any common factor other than 1. So the numerator and denominator don't have any common factor other than 1. Okay, and having terminating decimal expansion, and their decimal expansions are terminating. So what kind of property q must satisfy to get all these results, terminating decimal expansion result? So to get a terminating decimal expansion, okay, for the fractions, for the rational numbers, what property q, the denominators, okay, the denominators should satisfy. Okay, the denominators, what quality, what property the denominator should have to get a terminating decimal expansion, wherein the decimal expansion stops. Huh? Okay, so that is what we will understand now. So to understand this, what we will do, we will find the factors of the denominators. So we will find the factor of 8. So 2 4s are 8, 2 2s are 4, 2 1s are 2. Okay, now here, so 400s factors we will find. So 2 2s are 4 0 0, 2 1s are 2 0 0, 2 5s are 10 0, then 2 2s are 4, 2 5s are 10, 5 5s are 25, 5 1s are 5. Okay, now we will find the factors of 25 here. So 5 5s are 25, 5 1s are 5. So here if we see, okay, the fact in the factors of 8, what we have is we have 2 here. Here in the factors of 400, what we have is we have 2 and we have 5. Here in the factors of this denominator 25, the factors of 25, we have 5. So what we understand is that if we have you know the factors, the only factors 2 or 5 or both 2 and 5, only then we will get a terminating decimal expansion which stops, right? So the final answer we will write. So what property q must have? So the prime factorization prime factorization of q must have you know uh, powers of powers of 2 or 5 or both. So this is what is the answer. I hope you have understood this. Now we'll see question number 7. Write three numbers whose decimal expansions are non-terminating, non-recurring. So non-terminating and non-recurring type of decimal expansions we see for irrational numbers. Okay, we see for irrational numbers. So three examples they are asking us to give. So first example is the the number pi. So I has the decimal expansion which is non-terminating, non-recurring. So it is 3.1415 and it continues. So because it continues, you can just like write these dots like this. So it means it continues. Just write three or four digits. Then even the prime numbers inside the square root, they are also irrational numbers. So 2 is also a irrational number, and the decimal expansion is non-terminating, non-recurring. So it is 414, and you can just write dot dot dot. Then even prime numbers, so 3 is also inside the square root is an irrational number. So 1.7320. Okay. So this is also irrational. So three examples they had asked us to give, which we have given. It is very simple. Now we'll see the next question. So here we'll see question number 8. Find three different irrational numbers between the rational numbers 5 by 7 and 9 by 11. So they have given us two rational numbers. Okay, so let me just write, divide and write them in the decimal form. So 0.714285, and these numbers are repeating because they are rational numbers, right? So they will have either terminating or recurring decimal expansions. And even I will write the next the other number 9 by 11, and they are in they are rational numbers. So this is also non-terminating and recurring. So these are the two rational numbers, and they are asking us to write three different irrational numbers between these rational numbers. So it is very simple. You have to, with your own mind, whatever numbers you want, you can write them. So three irrational, numbers. Only what we need to remember is that the three irrational numbers have a property wherein the decimal expansions are uh, the decimal expansion the decimal expansions should the irrational numbers, the decimal expansions of irrational numbers are, they are non-terminating, non-recurring. So we should write decimal expansions wherein they should not look same in their decimal expansion. They should be different because they don't repeat, they are non-recurring. Okay, so 0 and between these two numbers, so 0.7 and 0.8. So any middle numbers you can choose, but don't just repeat the same numbers. So I will write 71589. So and just put a dot 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 like this. So these all these numbers are different. Okay, so like these three numbers we need to give. So another number is 7 because they should be between these. So 7, and then I will continue some different numbers here. So 0.73429, and I will put a dot dot dot. Another number is 0.7492, and I will just put a dot dot dot. So if you look at these numbers, these three numbers are between these two numbers, and they are irrational numbers because their decimal expansion is non-terminating, non-recurring. Just write different numbers and then put a dot dot dot, and this is our answer, guys. Very simple. Please like, share, comment, and subscribe my YouTube channel. And for online tuition classes, visit this website. Thank you very much, guys.